Hello, this is again Mike from Fair Repair, and today we are dealing with this nice Razer blade. As always, it had a previous owner, and yeah, it doesn't work anymore. This poor device suffers from a really bad connector damage. It's a connector where the DC-in jack cable plugs in. The previous owner shared pictures with me, and yeah, we don't even want to power it on at this moment, because it can be we can do more damage to this poor device. So the previous owner also stated it could have been damaged by the charger. Let's grab the charger. Looks absolutely fine to me. I've also inspected the rest of the charger, and everything looks fine. But let's do a more proper check. Minus, plus 20 volts. Sounds okay. So I don't think we have an issue with the charger, but probably some kind of another issue, board issue maybe. I have no idea. The previous owner stated the connector got mad hot, which is a really odd thing, actually, in my opinion. However, let's just open the device and see what's going on inside. Okay. Wow, this looks strange, but well, it should do the job. Otherwise the board looks really nice and clean still. And I still don't get what happened here, to be honest. The whole system looks actually really nice still. You know, I had really bad devices here on my bench in really poor condition, and yeah, this is still pretty nice. Well, a bit dusty and needs some cleaning, but it is still nice and cool. Yeah. Okay, let's see what we have here. Let's do some checks whether everything is like it is supposed to be. So we have an open line here. When we have a fuse, when we have probably the first MOSFET here. Let's go with beep mode. Beep mode? Yeah, first MOSFET. So let's see whether we have a short or something like that. Where can I put my ground probe? Here, this ground. So no short at the DC-in connector. Then no short in the middle, and no short at the output. Weird. Let's check all coils. Kilo ohms. This is near CPU probably, so okay. 1.9, okay. What do we have here? This is probably the GPU here. 0.5, okay. So the CPU is probably here and GPU here. So what else? Okay. Kilo ohms. This could be for the PCH. It's good. It's good. It's good. This could be for the memory. Well, actually I see no reason why it doesn't work. That's interesting. So at least on the board side everything looks fine. Maybe there's something wrong with the connector. Let's check it. So, and it does not work anymore. Looks good. I want to plug the charger and see what happens. Okay, let's plug the charger. Now I'm curious. Okay, plug the charger. And now? Ground here. 20 volt input. Okay, this is good. Comes to the first MOSFET. Passes the first MOSFET. Main power rail is present, 20 volts. So what else? Let's check a few voltages. Here, 3.3, 5 volts. What else? 1.05 volts. Okay, this can't be on. Battery here, nothing. What else? Nothing. Nothing. However, this looks fine to me. What is going on with this device? I need memory, and when we have to power it on. That's an interesting case. But actually, this could be a bad thing when everything looks normal. This could be a bad sign. Okay, let's plug the memory. Open the lid. Charger. So power button. Nothing happens. Now something happens. Keyboard light is on. And I have picture. Okay. Okay. Yeah, well. Sorry, nothing to show here. Maybe we can make something else from that, a small tutorial. Everything is working fine and as expected, so yeah, I just can't find anything. I don't know why the charger has overheated before. Maybe because of the missing battery, or I have no idea basically, but I have tested it with the charger and also with the benchtop PSU, and everything seems normal. So yeah, to have something useful, let us make a small tutorial, a small and basic tutorial with the most common issues you can have with a laptop. I differentiate between 3 different behaviors personally, which is no power, so a dead laptop. Then we have signs of life, but it does not power on. And the third is power on, but no picture. Well, all three behaviors have its pros and cons, but personally I like a dead device the most. So what can cause a device appearing dead? Well, most often you have an issue in the DC-in circuit, which means the main power rail does not pass the two DC-in MOSFETs. Here, this is the current sense resistor, 20 volts. Okay, so how does this work? Well, we have the DC-in connector, the jack, where the power comes in. When in this device it goes through fuse, which is fine and working, 20 volts. When we have a few farad beats, 20 volts, and then it comes to the first MOSFET. And here the issues may start, because it can be that we don't have the 25 volts at gate. Why is that? Well, it can be a shorted main power rail. You know, here at the current sense resistor we can measure the main power rail. How can we know if it is shorted? Well, we go just in resistance mode and check the resistance to ground. If it is below 10 ohms or so, it is shorted, and if not, it should be fine. So this is the gate voltage of the charging controller. Most often in a case of N-channel MOSFETs it is 25 volts. If you have P-channel MOSFETs here, it can be lower when 19 volts, let's say 13 volts, even 17 volts or 19 volts might be enough to open this MOSFETs. So a shorted main power rail can be an issue. What else? Oh yeah, missing AC detection. Almost every charging controller has an AC dead pin, which is basically a voltage divider connected to the DC-in here, to the charger plus. You'll likely find two resistors. Let's give an example. Here, pay attention to the AC dead line. This is the most common charging controller, a BQ24780S, and here we have the charger plus, and then the voltage, before we even reach the first MOSFET, the voltage comes here to a first resistor, and then we have a second resistor on the other side of the new created rail, which acts as a voltage divider. So if we divide 19 volts through 866 kilo ohms resistor and 133 kilo ohms resistor connected to ground, then we'll get 2.6 volts at AC dead, which is a perfect voltage for AC dead. Have in mind, 2.6 volts. If you have 2.6 volt at this line, AC OK should be asserted. And if AC OK is high, with 3 volts or maybe with 6 volts if it is connected or pulled up by rack N, then and only then you get the AC driver signal, which controls the DC-in MOSFETs Q1 and Q2. So all requirements to open these MOSFETs is a proper voltage at VCC, which also comes directly from the charger plus here through a small 10 ohms resistor R7 to the VCC pin. Then the rack N has to be created. It is supposed to be 6 volts. Then we need the AC detection pin with 2.6 volts, and then the ACO key will be asserted with either 3.3 or 6 volts. And if ACO key is high, then AC driver will activate the MOSFETs Q1 and Q2. So If something is wrong with the charging controller, when you have to dig deeper, of course. Often you have also shorted DC in MOSFETs. This happens. They can short between source and drain, when it can still pass to the main power rail, but the battery cannot be charged, because the charging controller acknowledges that the AC driver has not the proper voltage. It stays at 20 volts then, probably. Another issue can be a shorted MOSFET between source and gate. When the voltage indeed cannot pass the first or the second MOSFET, and yeah, the device just appears dead. And last but not least, we have the possibility of a shorted main power rail when the MOSFETs will of course shut down the system to prevent any damage. Yeah, this is what can happen in the charging circuit, but there are more possibilities for a dead device. It can be also a dead M controller, because the first voltage which will be created after the main power rail is present is the VREC3, the 3 volts LDO for the M controller. Actually, I have no idea where the M controller is. It is probably on the other side of the board, but you can do an indirect check. Like, you can check whether you have voltage at the power button. But we need to open the lid before, because otherwise it will be pulled low. So let's check. Here. Okay, 3.2 at the power button. I can't press it right now because I need 2 hands, but this is the power button and we have 3.3 present here. Okay, you just have to follow the line to the power button to get the clue. Okay, so well, the power button. So when the main power rail is present but the power button has no voltage, then you likely dealing with issue around the M controller. And there is even one more suspect when you are dealing with a dead device. It is actually the PCH. But you will know from the consumption of the device. A shorted PCH will consume a bit of current, like 100, something between 100 and 300 milliamps. So from where you can already assume something is wrong with the PCH. Because when the 3.3 always rail, here, when the 3.3 always rail is shorted to ground because of the PCH, the device might appear as completely dead, depending on the actual manufacturer. So yeah, these are the most common things for a dead device. DC in circuit and the M controller is most often possible to repair, but you can already assume with the PCH it is a bit more complicated to deal with it. So from my experience, these are the most common issues for that device. When we move to the no power on behavior, this is in my opinion the worst, because it can be almost everything. If you have a no power on behavior, then it can be a dead power button, for example. So the voltage does not drop when you press it. When you press a power button, the 3.2 volts are supposed to be pulled low while pressing it. and it comes back to 3.2 if you release the button. And so this has to work. Also, a dead CMOS battery can cause this behavior. Here we have 3.1, which is absolutely fine. But below 3 volts, it is a suspect, and you have to replace it. What else can cause a no power on issue? A wrong charger, for example. Especially with HP devices, a wrong charger or a bad charger can prevent the board from turning on. So at least with HP and also some other manufacturers, you have to pay attention that you work with a proper charger. Or like myself, I have a benchtop PSU with some adapters where I know they work. I know that. So then you can also come with these adapters, but these HP chargers have adapter detection built inside of the charger. Same with Dell, by the way, or also some Razer Blades have it, and Lenovo's have it. We all have some kind of adapter detection inside of the charger pins. Where is the third pin? Plus, minus, and adapter detection. 3 pins. So yeah, it is very important to work with the correct charger, with a known working charger of correct wattage. Yeah, a charger. What else? A defective lit switch can cause no power on. So when you have a defective lit switch, the device thinks the lid is closed. And if the lid is closed, the M controller will not deassert the power button, because the laptop is not supposed to come on when the lid is closed. It has to be open. So a faulty lid switch can cause was. I had not many on them, but it can happen. It can happen. Then especially with Acer devices, we can have some weird switches hidden on the motherboard, often near the memory slots. There are switches, and the switches act as some kind of chassis intrusion. So we have to be pressed so the device know I am closed and I can power on. If the switch is not pressed, then the device will not turn on, although it is absolutely healthy. Pay attention to that when you work with Acer devices. So I think these were the most common issue for a no power on behavior. Yeah, and then finally there is a behavior of power on but no picture. And the first thing you want to do when the device appears it is full on but no picture is to plug an external keyboard, an external USB keyboard, and check whether numlock or caps lock is responding when you press the related keys. Because if it is, you're dealing simply with a display issue, which means you have to troubleshoot the display circuit near the connector, whether you have the main power rail present there, whether you have the 3.3 rails present there, and whether you have the enables for the display present there, to decide whether you have a board issue or a panel issue. Everything is possible, always. So you have to troubleshoot that in case of caps lock is responding. But if caps lock is not responding, yeah, well, then it will be a bit harder. One approach could be to flash a known good BIOS firmware. Where is our BIOS chip? It is here, probably. Here's our small BIOS chip. It contains probably 16 or 20 or 32 megabyte of firmware, and yeah, is responsible to assert the logics after the board is full on. So BIOS can be an issue, and memory is a common issue. So we want to rule out bad memory then. The CPU can be an issue. So we have to, oh, here is the GPU. CPU is here. So we have to know whether all voltages are up, especially VCC system agent, VCC core, and other secondary power rails related to the CPU, like VCC IO. Usually there's another power rail which is called VCC GFX or VCC GT, and this rail you can actually ignore almost always, because it is not supposed to come up before some load, before we have some load with the CPU. It only comes up under load. So there is probably no issue if just VCC GT or GFX is missing. You can ignore that almost always. So the CPU has to be full on with all power rails. Memory, I told that already. On a DDR4 system, there are supposed to be 1.2 volts. I think the related coil is here, this one here, or this one of these. And then you can of course have an issue with the dedicated graphics, which there are also a few secondary power rails present besides the core phases. These three phases are for the GPU core, but we have also the memory for the GPU, which is also important and shorts out often. Everything below 10 ohms is very, very suspicious here. Let's power on the device and do a few checks. So board is on. You see here. So what did I told? We have 3.3 here, and we have the 1.05 for the PCH here, which can also be a symptom of no power on, a shorted 1.05 volts rail, which is related to the PCH again. A dead PCH is the most common issue. I told that already. Okay? So, then memory. Yeah, here we have the 1.2 volts for the memory and 2.5 volts, which is also related to memory, but it is a secondary power rail. Most often you even don't have such a big coil here. It is most often a very small inductor, like a Farid bead, something like that. So what else? What do we have here? A 1.8 volts power supply, which is also very common on modern devices. if I remember correct, it connects to the... Oh, is it off? No. Well, I can't give a good example here on this board with the power rails because we have some power saving features running here. Maybe when I give some load. Okay. A small stretch test. Okay, let's run a benchmark. Then we should have more luck with our voltages here. So 1 volt. Yeah. And also this coil has no voltage. Here we have voltage, 1 volts. I guess the 0.5 are the actual VCC GT rail. And here it is our core rail, 1 volts. This could be system agent, GPU, 0.9 volts. Also the 1.8 is up. Another 0.9. This could be a secondary core rail for the GPU actually. And here 1.5. Probably VRAM, the GPU memory. 1.5, okay. So what is that? 1 volts. Could be PEX. So yeah. And this voltage here at this capacitor, at this single capacitor here, you won't see without load. Let's check. So, stop the benchmark test, and now, you see, we don't have voltage there anymore, which is very important to know, because only under load, I told you, only under load. Yeah, so it can be that you have missing voltages in the late sequence, like you have missing RAM voltage, which actually would be the best, because here you can at least replace a memory module and see what happens. Because the other reason for a shorted RAM power rail would be a dead CPU, because the 1.2 volts are also connected to the CPU. If you have a short there, let's say below 30 ohms, then you have a problem, a big problem. So, and then of course the CPU itself, when you have missing voltages where it will be very hard, because let's power off the device again to show you now. Okay. Let's start with the memory. So how can I know I have bad memory? with a resistance check, for example. 110 ohms, okay? With module plugged. When I remove the module, the resistance will raise to 165 ohms. So however, a value above 100 ohms will be good. If you have a low value like 40, 30 ohms to ground, then you likely have an issue at the power rail. Then the CPU. A CPU power rail is hard to diagnose because you have already very low resistance to ground. 4.8 ohms at VCC GT. No, here is the core rail. 2.9 ohms. This is the core rail. Yeah, 3 ohms. 2.93 ohms. This is the core rail. This is VCC GT. 5 ohms. And then (14.8), which is likely the system agent rail, and here 30 ohms, which is another secondary power rail, VCC IO or something like that. So yeah, hard to troubleshoot because we have already, yeah, I show it again, 3 ohms. Okay, internal resistance of the probes is 0.6, so it is actually 2.6 ohms resistance to ground of the power of the core power rail for the CPU, and it is fully working. How will you know whether the CPU is shorted or not? You can only assume if it is lower than, let's say, 2 or 1 ohms. Otherwise, it can be fully working, fully normal. Yeah. So it is even worse with the GPU circuit. Let's check resistance to ground here. 0.8 ohms. No joke. 0.8 ohms. And it is fully working. Does benchmarks. Internal resistance is 0.5. And core rail has 0.8. So we have basically a resistance of 0.3 ohms to ground. 0.3 ohms to ground. This is no joke. This is absolutely normal. So you are not able to assume whether you have a shorted core power rail of the GPU. It is not possible. Okay? So you have to find another approach to diagnose a shorted high-end GPU. Okay? For example, the secondary power rail, for example. Here it is slightly higher, 1.6. So basically 1 ohms. Okay? So what else? I told something about the VRAM. So here we have to expect a higher resistance to ground, above 30 ohms. Yeah. 37 ohms to ground, yeah? It can be even lower. It can be 30 ohms, maybe 25 ohms on a laptop motherboard, but below would be really suspicious already. We had 1.5 volts here. And here this is the PEX line, PEX, probably, with 53 ohms to ground. Okay? So these are healthy values. What about the 1.8? Kilo ohms. 1.8 has always to read kilo ohms, same as 5 volts and 3.3, and then we are fine. And I almost forgot about the 1.05 volts here for the PCH. 58 ohms to ground, which is absolutely healthy. But let's say, from my experience, below 20 ohms, already very suspicious value. So from here, even from the static resistance measurements, you can get a rough idea whether something is wrong with the power rails. Okay, this is how I work. And if there is still no clue, well, you can of course inject voltage, but of course you have to be very careful to not exceed the proper working voltage of the device, otherwise you will burn a CPU or a GPU in worst case. Okay? So I hope this was an interesting overview about the common faults you can challenge on a board with the 3 different behaviors: no power on, and no picture. And yeah, I hope I can share something more interesting with you the next time. Thank you for watching, as always. Bye.